Today we discuss this following problem. If 2 is an eigenvalue of 3 minus 1, 1, minus 1, 5 minus 1, 1 minus 1, 3, without using its characteristic equation, find the other eigen values. So we have given an eigenvalue of a matrix. We are given one eigenvalue of a matrix, so we want to find other eigenvalues without using the characteristic equation. The method is simple. We have a matrix that is 3 minus 1 1 minus 1 5 1 1 2 5, and we know that 2 is an eigenvalue, or 2 is an eigenvalue. We want to find other eigenvalues. Clear? Problem is clear, and we are not allowed to use the characteristic equation. So what we do is we do two things. First, we find the determinant of the matrix, given matrix. So if let A is equal to 3 minus 1 1 minus 5 minus 1 1 minus 1 3, can find the determinant 3 into 5 3 minus 1 1 minus, we are expanding along this row, so minus 1 into this part, minus 1 1 minus 1 3 plus then 1 into this minor 1 5 minus 1 1. That simplifies to 36. So we now know that determinant of A is 36. Now we go to, we have the matrix, we know determinant is 36, and sum of diagonal elements, you can find that 3 plus 5 plus 3 is 11. So we assume that lambda 1 and lambda 2 be the other two eigenvalues. We have the determinant of the matrix 36, sum of diagonal elements 11. We assume that lambda 1 and lambda 2 the other eigenvalues. So we know that lambda 1 plus lambda 2 plus 2, sum of the eigenvalues is also sum of the diagonal elements. So whenever you have eigenvalues and diagonal elements, this relation holds. Sum of the eigenvalue is sum of the diagonal elements. So lambda 1 plus lambda 2 plus 2 is equal to 11, and also the product of the eigenvalues is the determinant of the matrix. So 2 into lambda 1 lambda 2 is the determinant of this matrix. We have found it earlier, that is 36. So you can say 2 into lambda 1 lambda 2 equal to 36. So we find lambda 1 plus lambda 2 plus 2 is equal to 11. So we know lambda 1 plus lambda 2 equal to 9, and 2 into lambda 1 lambda 2 equal to 36. So lambda 1 lambda 2 equal to 8. So we try to find, we search for two numbers, lambda 1 and lambda 2 satisfying lambda 1 plus lambda 2 equal to 9 and lambda 1 lambda 2 is equal to 18. So you can easily get that they are equal to, lambda 1 is equal to 3 and lambda 2 equal to 6. So you can write lambda 1 is equal to 3, lambda 2 is equal to 6. So how did we arrive at this solution? We arrived at, first we found the determinant of the matrix, then we found the sum of the diagonal elements, and we know that if lambda 1 and lambda 2 and lambda 3 are the roots, here we know the one root is 2. So if lambda 1 and lambda 2 are other roots, then sum of the diagonal elements is sum of the roots, that is lambda 1 plus lambda 2 plus 2 equal to 11. And also we know that lambda, the product of the diagonal elements is determinant of the matrix. So 2 into lambda 1, lambda 2 equal to 36. So we get lambda 1 plus lambda 2 plus 2 is equal to 11. So we get lambda 1 plus lambda 2 equal to 9 and 2 lambda 1 lambda 2 equal to 36. So lambda 1 lambda 2 equal to 8. So we search for two numbers, lambda 1 equal to 3 and we easily get lambda 1 equal to 3 and lambda 2 equal to 6. So this is the general method of solving such equations. Find lambda 1 plus lambda 2 and lambda 1 lambda 2, then find two numbers whose sum is lambda 1 plus lambda 2 and product is lambda 1 minus lambda 2. So you may have a natural question. Suppose that you cannot directly find such two numbers. So what we do is, suppose that we have lambda 1 plus lambda 2 and lambda 1 lambda 2. You can easily find lambda 1 minus lambda 2 is equal to lambda 1 plus lambda 2. You can take the square, you can find the squared, minus 4 lambda 1 lambda 2 will give you lambda 1 minus lambda 2 squared. So from that you can get lambda 1 plus lambda 2 and lambda 1 minus lambda 2. You can add or subtract, you can easily find lambda 1 and lambda 2. But here we directly got, so no problem. Thank you very much. If you like this class, please ask for more questions. Thank you very much.